Dear friends, this is the part 2 of my previous video on ladder sums made easy. So we will see and we'll solve the part 2 of the sum which I have solved in part 1. So in the same sum what we have seen earlier, we have a uniform ladder of 3 meter long and its weight 200 Newton. It is placed against a wall making an angle 60 degree with the floor. Here in this case this 60 degree is not there. Instead what they have given here is, if the force P is not applied, what should be the maximum inclination of the ladder with the horizontal. Okay, so they have asked what should be the maximum inclination with the horizontal, so that there is no slipping of it with the man at top. Okay, remaining things are same. The coefficient of friction what they have given between the wall and the ladder is 0.25. so here we have, instead of 60 degree we have theta, and that between the floor and the ladder we have, it is 0.5. so it's mu c is 0.25, mu a is 0.5, and we have a man of 1000 Newton which is resting at the top, means at point C. So now what we have to find in this is this angle theta. Okay, so we'll just apply the steps what we have learned in our previous video, and then we'll try to solve this sum. Okay, so our first step is to draw the free body diagram. Okay, so this we have got as 1.5 meter, which is the proof that this 200 Newton weight of the ladder is acting at the middle, at the center of the ladder. Then we have NC perpendicular to BC and A perpendicular to AB, then FC, and then FA. We don't have P here as it is given in the question that the force P is not applied. Okay, so we don't have P in this question. Okay, so now we'll apply the second step, which is nothing, basics of trigonometry, and we'll try to find the values of AB and BC and AD. Okay, in this case we don't know theta, so we'll get the values of AB and AC in terms of theta. That's it. Remaining things and remaining steps will be same. Okay, so here we know h is 3 here, and hence this will be 3 cos theta. Okay, so since AB is adjacent, we have applied this formula. Okay, similarly we can find BC. To find BC is base, opposite, sorry. So we have applied this formula of sine theta, and h is 3 here, and this will be sine theta. And for AD is again the base here. To find the base we have to apply this cos theta formula. For this we have hypotenuse as 1.5 meter. Okay, so instead of 3 we'll have 1.5 meter here, and this will be cos theta. Okay, so we have done with the second step. Now we'll apply the third step. Okay, so here we have got all the values of AB, BC and AD. Okay, so now the third step is to apply the equilibrium condition. Okay, so in this, the first condition of equilibrium is sigma fx is equals to 0. We'll assume that sign of convention, right side forces positive, left side or acting towards left forces negative. Okay, so here we have one force is acting Fa as positive in the positive direction, and NC is acting in the negative direction. Okay, so we'll have Fa minus NC is going to be equals to 0. Now we already know that FA will be equals to mu A into NA. Similarly, FC will be equals to mu C into NC from the standard formula of frictional force mu into N. Okay, so we can write FA as mu A, and mu A we know as 0.5, so we can directly write it as 0.5 NA, and this is going to be equals to NC. Okay, so this we can assume as equation 1. Okay, we'll apply the second condition of equilibrium here. Sigma Fy is equals to 0. We'll assume the sign of convention as upward as positive and downward as negative. Okay, now we have vertical forces NA, 200, 1000 and FC. So we have 4 forces here. So we'll apply the sign of convention and write all the forces. Summit of all the forces. NA positive, minus 200, 200 is negative, 1000 will all again negative, acting downward, and now we have FC. This is going to be positive. Okay, so we know FC can be written as mu C into NC, and mu C is 0.25, so we can write this equation. And similarly, we have NC is equals to 0.5 NA. Okay, so this value also will put. So NA we have this, both the things we can take it here, okay, to make it positive. So this we can write mu C is 0.25, and NC from this equation we can write as 0.25 NA, sorry 0.5 NA. So this is going to be equals to 1200. Okay, so if we solve this equation, we'll get to know the value of NA. So we have 1 and 0.25, so this will be equals to 1.125 NA, and this is going to be equals to 1200. This implies that we'll have NA as equals to 1066.67 Newton. So we have got NA. Okay, similarly we can get NC. If we apply the put the value of NA in equation 1, here we can get NC easily, 0.5 NA. So NC will be equals to 533.33 Newton. Okay, so we got both the values of NA and NC by applying these two conditions of equilibrium. Okay, so now we'll apply the third condition of equilibrium, which is nothing but sigma m at any support is equals to 0. Okay, now which support will take? See, at support A we have 2 reactions, at support C we have 3 reactions. So I have told you in my previous video that you should choose the support which has maximum reactions. So we'll choose the support C, and this is going to be equals to 0, means summation of all the moments at support C is equals to 0. Now we'll apply the sign of convention, we'll assume it. So clockwise positive, anti-clockwise negative. Okay, so now we'll take moment of all the forces acting about point C equals to 0. So for this force 200, this will create an anti-clockwise moment, and hence this force will be negative. So 200, and we'll take the perpendicular distance as this one. Okay, so this dB. So since this is equal, so AD will be equals to dB, and which is nothing but it is going to be equals to 1.5 cos theta. Now for this case we have force FA, So this will again create an anti-clockwise movement at C, and hence this will be negative FA. And since this is horizontal, we'll take the vertical distance BC, and BC we have 3 sine theta. So we'll apply 3 sine theta. Now we'll take this force NA. NA is going to create a positive moment at C, and hence NA is going to be positive. So plus NA into, this is vertical, hence we are going to take this horizontal distance AB. AB is 3 cos theta. This is going to be equals to 0. Okay, now we'll solve this equation. We have cos theta here, and then we'll have cos theta here. Okay, so we'll try to take the cos theta part this side, and we'll keep it here itself, and we'll take the sine theta part to the other side to make it positive. Okay, so we have FA. So value of FA can be written mu A into NA. Okay, mu A is 0.5, NA we have already found. Okay, so we can write it as this will become positive. Okay, so this portion will become positive since it is going this side, so we can write it as positive. So FA is mu A is 0.5 into NA. NA is 1066.67, and this will be equals to 3 sine theta. This is going to be equals to NA. NA again 1066.67 into 3 cos theta, and this will be negative minus 200 into 1.5 cos theta. Okay, now once we'll solve this, we'll get the value of this here if we'll solve this, we'll get the value as this will be 1600 sine theta. This, if we'll solve this, we'll get the value as $2,900 cos theta. Okay, so now we can do one thing. Since this is sine theta and this is cos theta, we can bring cos theta here. So which is sine theta by cos theta. This will become 2900 by 1600. So this will get cancelled. If we'll solve this, this will become tan theta. This sine theta by cos theta will become tan theta, and 29 by 16 will give you the value as 1.81. And if you'll solve this, you will get the value of theta as tan inverse 1.81. So theta value will get as 61.11 degree. That's it. So I hope you would have understood the sum. If you have any doubts, you can always reach out to me. I just wanted to conclude now. So what we have done in the part 1, we have found the value of P as 24.368 Newton, and the value of theta as 61.11 degree. Thank you for patiently listening and have a wonderful day.